into the third part of the chapter 14 notes. And this one's broken into kind of a lot of pieces because there's a lot of content there. So for the third part, we're just going to look at a little bit more vocabulary and then take more ideas, and eventually we'll get to another computational portion of this. So first, for this piece of notes, I'm just going to go through a few more vocabulary terms, think of some reasoning behind what's going on, and then talk about what this is actually going to lead into. Okay. So on here, we've talked a little bit about how confidence intervals relate to margin of error. So we've looked at confidence intervals, we've looked at those formulas, and you should remember that the margin of error is, of course, just the plus or minus part on the other side of your estimate. So we're basically just accounting for any error that we might make by using the sample mean as an estimate for the population mean, or vice versa. Okay, so to summarize what we've talked about, remember that a higher confidence level, we can call it C, it implies that we have a larger margin of error. So larger margin of error. Okay, so we could call the confidence level C, we could call the margin of error M. So if we have a higher confidence level, that implies that we have a larger margin of error. What this is saying is there's more room for error with something. So if I make a confidence interval and I say, oh, I'm 98% confident that this is going to happen, well, we know that what that does is it makes our bell curve larger, it expands that out, and so if we have the mean at the middle and we're making the bell curve larger, we know we're really subtracting a larger margin of error and adding a larger margin of error to make that bigger. Whereas if we say have 95%, it's still pretty far spread, but then we're kind of pulling those sides in a little bit more, so the margin of error would become smaller. So for this, we could look at it formulaically or think about it intuitively. If you're saying you're 98% sure about something, intuitively would think that we have more of a chance of being incorrect about that. Right? If I said, oh, I'm like 70% sure that this thing's going to be happening, then I'm saying that I'm kind of sure, but I'm not super sure. But if I'm like, oh, I'm 99% sure that's going to happen, then there's more of a chance that I could be wrong. So intuitively, it's sort of what we're looking at with that concept. Okay, so looking further into that, we can say a lower confidence level C produces a smaller margin of error, of course. So smaller margin of error. Okay. Looking at this in terms of, say, 90% and 98% confidence intervals, we found that 98% confidence intervals have a higher margin of error than a 90% confidence interval. So I think in class or in the other notes, I guess you should say we did it with 95%, but if I were to do it with 90%, it would have the same idea there. Okay, and this is because we are moving further away from the mean. So if we're moving further away from the mean, we know that the z-score is going to be larger. Right? Z-score represents the number of standard deviations. When we move out further away from the mean, we know our number of standard deviations is larger, therefore our z-score is going to be larger as well. Okay, so now the question is, why does this matter? Okay, well basically we use it to conceptualize and understand the usage of what we call significance tests. So we're going to take this another step farther and perform what we call significance tests. These ideas are really important in understanding the reasoning behind those significance tests. Okay, so recall that we have statistical significance when numerically something is so likely or so significant, we conclude that it's actually true. So we looked at this vocabulary term a while ago, I think it was chapter 7, probably chapter 8, in one of those two. And we found that statistical significance happened when numerically something's so likely to happen that we conclude it would actually be true. But in order to determine if something is statistically significant, we have to kind of take a few steps. So our first step would be to, of course, hypothesize. So we're going to hypothesize, okay, about the data or the question we're asking. Okay, so this kind of goes with, a scientific experiments, except for we're looking at a statistical experiment. So first we'll start by hypothesizing something's going to happen. Okay, and then after that, we would of course want to test to see if this hypothesis is true. So we would have to test this hypothesis. And then what we need to do is make conclusions. So we'll draw a conclusion based on the level of confidence or our levels of the levels of confidence that we have. So we would make conclusions based on our confidence levels. Okay, but in order to start this, we have to have two different hypotheses. What this kind of helps us with is figuring out what we are going to accept to be true, or it's going to be highly likely that it's true, or what we're not going to accept as true. So we're looking at two different hypotheses every time we do this. In the next video, I'll actually take a look at these hypotheses, and then eventually we'll break all these down into calculations that we'll refer to as the significance test.